So we're going to come to this graph here, and we have a plot of acceleration versus time and a plot of velocity versus time. And what I want to share with you is these two graphs are going to represent the same object at the same time. Okay, so this is two motion graphs for the same object. Okay, so this is the same object in motion, and we want to understand like how this object is moving and what is happening, okay? So I think it's important first to take a look at the velocity time graph and understand all the components of it, okay? Because right now, we understand the position time graph. So looking back at a position versus time graph, okay? If I have a graph that looks like this, let's say. Good so far? All right, so this is my graph. What does it mean that I have a positive slope here? That we know that the what? Say it again. We know that we have a positive velocity, right? And what does a positive velocity mean? That what is our object doing? What's positive versus negative velocity mean? Remember, pluses and minus don't mean slowing up and speeding down. They now mean one's going right, one's going left. For the rest of the lesson, I'm going to be using right and left, and I'm going to assume that right is the positive direction. Everybody good? So right and left, right is the positive direction, left is the negative. So what this means is I have a positive constant velocity, and I'm going right, okay? What does it mean when I have a horizontal line? It means I'm not moving. I know velocity is 0. And what does it mean when I'm going left this whole time? That I have a negative velocity. What does it mean to be on the x-axis for a position time graph? It just means you're at your starting point. Okay, so that means that's your starting point, like your initial point. Okay, does that make sense? So if we have this graph here, right, this point right here is at a position of 0. Okay, so this means I'm moving which direction again? Right. This means I'm moving left. If I'm above the x-axis, it just means I'm to the right of what we consider a 0 position. And here, it just means I'm to the left of the 0 position. But regardless, the whole time I'm going down, I'm moving left. Is everybody okay with position versus time? All right. Now, velocity versus time, not the same. Okay? So I would strongly suggest taking good notes, going on later, making note cards, memorizing these, because over the next couple weeks, we're going to be dealing a lot with these graphs. And the better you understand it now, the easier your lab is going to be, and the easier your homework is going to be. And you want to know this as fast as possible. So here's the thing that's different about a velocity versus time graph. For a velocity versus time graph, okay, what does it mean to be above the x-axis? It means you're going to the right, okay? So this is different because on here, when I was above the x-axis on a position versus time, that did not guarantee I was going right. I had to be going upward to be going right, and when I'm going down, it means I'm going left. That is not true for a velocity versus time graph. For a velocity versus time graph, if you are above the x-axis, you are moving right. If you are below the x-axis, you are moving left. Everybody good? That's number one big idea for velocity versus time. Second, if you are on the x-axis, what does that mean about your object? That you are you are not moving. So right here at 6.5 seconds, you're not moving. Right here at 10 seconds, this object's not moving. Okay? Everybody good so far? So you need to know that. X-axis for velocity means you're stopped. X-axis for position versus time means you're just at the 0 position. Completely different meanings. Coming back here. Next, if you are stopped on 0, what is happening as you get further and further away from 0? You are speeding up. Now let's be careful about this. What happens if you're going in the negative direction, getting away from 0? Speeding up, you're just speeding up in the opposite direction. So, on here, above means left, below means right. Moving away in either direction means you're getting faster, which means moving toward the x-axis means you are slowing down. So that's the second big idea. Third big idea, what is the slope of the velocity versus time graph? It's acceleration. So right here, what do I know about my acceleration? It must be positive acceleration. And then we come over here, and what do we know about acceleration? It's negative acceleration. And then right here, we know that it is positive acceleration. So acceleration is the slope. So 3 big ideas right there. Very, very big ideas that you must know. And it's helpful if you try to know them sooner than later. Above the axis is right, below the axis is left. Moving away from the x-axis, speeding up. Moving toward the x-axis, slowing down. Positive slope, positive acceleration. Negative slope, negative acceleration. So these are 3 very, very big ideas. So we have that. Here's the other thing. If you can get the value of the acceleration, I know it's positive, turns out from 0 to 4 seconds, all right, it's the same as the acceleration here from 0 to 4 seconds. So the slope of this line, I already know without calculating it from this graph that the slope of the line must be 4 because from 0 to 4 seconds, I'm going 4 meters per second, 4 meters per second, 4 meters per second, right? It's constant, okay? So this is that same positive acceleration from 0 to 4 seconds. These 2 represent each other. So you guys are going to end up going between the 2 graphs, okay, both ways. So if you have this, you know you need to draw a slope of 4, right? If you start with this, you need to know that the slope is 4, and that'll create a horizontal line over here. All right, next. Here I have negative acceleration from 4 to 9. So again, 4 to 9 on the other graph, it's negative acceleration. Again, this is the same object. We're just representing it with different motion graphs, and we have 3 motion graphs. Position versus time, velocity versus time, acceleration versus time. So here, I know that the slope of that line here, if I actually calculated the slope, it should be negative 8, and that's why I have a horizontal line at negative 8 here. So this is negative acceleration. And again, here, a positive slope means positive acceleration. That's this little piece right here. All right. What I want to look at next is the speeding up, slowing down versus the negative and positive velocity. So here, is my velocity positive or negative? So let's look at the values. I have 5, 6, 7, 8, 9, 10, all the way up to 20. Are those positive values or negative values? So I know my velocity is positive. I'm moving away from the x-axis. So am I speeding up or slowing down? I'm speeding up. So in this whole section, I have positive velocity and I'm speeding up. In my brain, I'm like, that's 2 positives. 2 positives multiplied make a positive acceleration. Now we come over here. In this section, is my velocity values, are they positive or negative? Positive velocity. However, we're going closer to 0, which means we must be slowing down. All right, now down here, what kind of values for velocity do we have? We have negative velocity. However, we are moving away from the axis, so we must be speeding up. Again, they're kind of like opposites. A negative velocity, but speeding up. that gives you negative acceleration. So that is why even though we're slowing down to a stop and speeding up, we have negative acceleration that whole time. All right, and then we have this last piece here. What's my velocity? Negative velocity, but we are slowing down, so it's like having two negatives. We multiply those together, we get a positive acceleration. So again, acceleration, two components. You have to look at your velocity. Is it positive or negative? And then you also have to consider, are you speeding up and slowing down? So in practicality, if we are taking a look at this example down here, we have a college physics department attaches a motion sensor to a soccer player. At one instant, the motion sensor indicates that the player's instantaneous motion was 20 meters per second. Okay, was negative 20 meters per second squared and positive 10 meters per second. So assuming that he wants to move in the positive direction, we want to describe his motion. Okay, so with that said, right now at the snapshot, is he moving in a positive or negative motion? Right now in that snapshot. So this is the information we know. How do you know he's moving in the positive direction? Because we have a positive velocity. Okay, we have a positive velocity right now. What do we know about the acceleration? The acceleration is negative. Okay, so if we have a positive velocity and a negative acceleration, what do I know about my object? It must be slowing down, because if you have a negative acceleration, remember, we need opposite things to happen here. So that would be similar to this graph. So over here, we have this graph. We had positive velocity here, and it was speeding up. And then from 4 to about 6.5, we had positive velocity, but we were slowing down. And then here we have negative velocity speeding up, because again, these graphs, it's the same object, so all these things are happening simultaneously. And then over here we had negative velocity slowing down. So over here, if I have negative acceleration, right, negative acceleration, if I have positive velocity, I have to be slowing down. So what this means is that he is slowing down in the positive direction. That's what these two pieces of information tell me. Slowing down in the positive direction. So if we were looking at the graphs, this would be a V, this would be a T, right? Then he's positive, but he's slowing down. So that's what it would look like.